All right, so the next shape we're going to deal with is what's called a parallelogram. Now, we didn't spend a whole lot of time earlier talking about what a parallelogram was. I'm just kind of saving that for this. I'm not going to ask you guys to memorize a whole bunch of different properties. You probably kind of have already picked up on a couple of them. But I want to illustrate what's happening when we're trying to find the area of these things. So here is my parallelogram. What it means for a shape to be a parallelogram is that the top and bottom sides are parallel to each other and the left and right hand sides are parallel to each other. They are also the same length. So in my head, this has always kind of been a rectangle that's kind of starting to droop a little bit. All right, it's just like it's come out of square, like it's starting to fall down. So what's happening here, at least in my mind, is when we're trying to find the area of this thing, right? And I'll jump ahead a little bit and I'll come back. You take the base of the figure times the height of the figure. Now that is almost exactly what we did yesterday with length times width for a rectangle and a square. It's slightly different, and I'm kind of keeping it different because I want you guys to see that this is kind of what's happening here. So the base of this shape is the flat part that it sits on, and then the height of it is what runs, that is not a very good perpendicular, is how tall it is through the center. All right, if I were to draw a perpendicular line straight up and down, how tall is it there? Now, in my head, the way this works is that triangle that I've created over here on the left, if I were to take a pair of scissors and cut that off, that triangle would fit perfectly right here in this space and create what would have been a rectangle. That's why I think the formulas are so similar. I've got length times width, base times height. It's really the same thing if you kind of in your head can kind of snip that and move it over. The big thing is you do not use the sides to find the area of a parallelogram. So if let's say that this were say 5 inches and this were say 10 inches down here, you guys cannot find the area of this thing because I don't know how tall it is through the center here. I need to be able to find that. I'm not going to ask you to do that. That's not what we're driving at here, at least today. So keep in mind, perimeter, add up the sides, parallelograms, you need the height through the middle, and I will give it to you. Some of these, however, the height might be dropped outside of the figure over here. So you'll have, and you'll notice them because it's a completely different color even. So if this thing were, say, 10 inches across the bottom and then, say, 7 inches over here on the outside, this thing's going to have an area of 70 square inches. All right, so there's your formula. If you need that, kind of keep it separate from anything. Base times height, vertical height through the center of the figure. So we can find the area of these really quick. The area of this guy here is 6 times 4. That is 24 square feet. This one over here, same thing. Base is 10. Height, this is what I was talking about here. Your height is outside the shape, but you're still going to just multiply your base and your height. 40 square miles. And then the one down here at the bottom, 12 times 8. This guy has an area of 96 square yards. Okay, make sure you're inputting your units correctly. Square units, square inches, square feet, square miles.